Hello friends, welcome to this video. In this video, we would solve CSIR-UGC NET December 2015 question consisting of 3 marks. In this question, we need to find the extremal for this functional, right? We are given 4 options and we are also given that C1 and C2 are arbitrary constants, that is, they can take any value. So, for calculating this, we must know what form our functional is in. That is, we must know, we can clearly see that it consists of x, y and y dash. So, the Euler's Lagrange equation in this case is f of y minus d dx of fy dash is equivalent to 0. We are given f as y square plus y dash square minus 2y sine of x. So, firstly we will calculate the partial derivative of f with respect to y. We have 2y minus 2 sine x. Here we have kept x and y dash as constants. Next we calculate fy dash, that is the partial derivative of this f with respect to y dash. So, we clearly obtain 2y dash. Putting these values in our given equation, what we obtain is 2y minus 2 sine x minus first derivative with respect to x of 2y dash is equal to 0. Rewriting this equation, we obtain y minus sine of x minus y double dash is equivalent to 0, or y double dash minus y is equivalent to minus sine of x, right? So, this equation is a second order non-homogeneous. Non-homogeneous means the right hand side is not 0 with constant coefficients. So, the solution y would be y of c plus y of p, that is the sum of complementary solution plus particular solution. So, let us calculate that. Firstly, we will calculate the complementary solution yc. How can we calculate that? First of all, we will write the auxiliary equation corresponding to the given equation, which would be d square minus 1 is equal to 0, where what is this d? This d is the first derivative with respect to x. So, solving this equation gives d is equal to plus minus 1. Here the roots of this equation are real and distinct. So, yc is equivalent to c1 e to the power x plus c2 e to the power minus x. If you do not remember this form, you just have to go back to the theory of ordinary differential equations. So, here c1 and c2 are constants and these are arbitrary in this case, right. So, this is our yc. Next, let us calculate yp. There are several methods to calculate the particular solution, like the method of undetermined coefficients or the variation of parameters. In this case, I am using the direct method. The direct method is, I will just write the operator form of this equation here and the right hand side of the given equation. And what you have to do in this case is that you just have to replace this d square with the negative of the square of the coefficient of x. The coefficient of x is 1. So, basically you will just replace d square with minus 1. So, let us do it. 1 upon minus 1 minus sine of x, which is 1 by 2 sine of x, right. So, from looking at this complementary solution, you can rule out these two solutions, right. This cannot be solution, this cannot be solution because of these forms, right. So, from these two, what can be the solution? For that, we need to see what the particular solution is. The particular solution we obtained is half sine x. So, our solution would be b is equal option B, that is y is equal to c1 e to the power x plus c2 e to the power minus x plus half sine of x, right? Thank you for watching this video. I hope you like it.